Hello everyone and welcome to this interesting session on deep learning interview questions. Now deep learning is a hot buzzword nowadays and has firmly put down its root in a vast multitude of industries that are investing in fields like artificial intelligence, big data and analytics. So for example, Google is using deep learning in its voice and image recognition algorithms, whereas Netflix and Amazon are using it to understand the behavior of their customers. Even Tesla is using deep learning in their self-driving cars. Now imagine how much potential deep learning has in revolutionizing the world and the way we work around things. Now this growth of deep learning and its application has led to the growth of deep learning jobs even. For example, we have the data scientist, we have machine learning engineer, we have artificial intelligence engineer, and much more roles. So let's begin our deep learning interview question and answer session and understand what are the typical questions which are being asked in deep learning interview. So the first and foremost question what any deep learning interviewer asks is the basic understanding of the relationship between machine learning, artificial intelligence, and deep learning. So basically, artificial intelligence is a technique which enables machine to mimic human behavior. And machine learning is a subset of artificial intelligence technique which uses statistical methods to enable machines to improve with experience. Now, deep learning, on the other hand, is a subset of machine learning which makes the computation of multi-layer neural network feasible. It uses neural networks to simulate human-like decision making. Now, coming to the second question, do you think deep learning is better than machine learning? And if so, why? Now, though machine learning algorithms, the traditional machine learning algorithms, solve a lot of our cases, but they are not very useful while working with high dimensional data. Now, that is where we have a large number of inputs and outputs. For example, in case of handwriting recognition, we have large amount of inputs where we have different types of input associated with different types of handwriting. Now, another major challenge is to tell the computer what all features it should look for that will play an important role in predicting the outcome as well as to achieve better accuracy while doing so. So these are some of the few shortcomings what machine learning have, and deep learning overcomes all of these shortcomings. Now coming to our third question, which is what is a perceptron and how does it work? Now actually our brain has subconsciously trained itself to do a lot of things over the years. Now the question comes, how does deep learning mimics the functionality of the brain? Well, deep learning uses the concept of artificial neuron that functions in a similar manner as the biological neuron present in our brain. Therefore, we can say that deep learning is a subfield of machine learning concerned with algorithms inspired by the structure and the function of the brain called artificial neural networks. Now, if you focus on the structure of a biological neuron, it has dendrites which is used to receive inputs. Now, these inputs are summed in the cell body and using the axon, it is passed on to the next biological neuron. Now, similarly, a perceptron receives multiple inputs, applies various transformations and functions and provides an output. Now, a perceptron is a linear model used for binary classification. It models a neuron which has a set of inputs, each of which gives a specific weight. Now, the neuron computes some function on these weighted inputs and then finally it provides the output. As we know that our brain consists of multiple connected neurons called the neural network, we can also have a network of artificial neurons called the perceptron to form a deep neural network. Now coming to the next question, what is the role of weights and biases? Now for a perceptron, there can be one or more input called bias. While the weights determine the slope of the classifier line, the bias allows us to shift the line towards left or right. And normally bias is treated as another weighted input with the input value x in our case. If you have a look at a typical perceptron, what it receives is a set of input. Now these inputs are not just input which it gathers, so weights are an additional input which it takes, and according to that it computes and provides an output. Now which brings us to the next question, which is what exactly are activation functions? So activation function translates the inputs into outputs and it uses a threshold to produce an output. So the activation function decides whether a neuron should be activated or not by calculating the weighted sum and further adding the bias with it. And the purpose of the activation function is to introduce a non-linearity into the output of a neuron. There can be many activation functions like linear or identity. We have the binary step, we have sigmoid, we have the tanh, we have ReLU and SoftMax. These are a lot of activation functions which are being heavily used in the deep learning industry. So one should actually know about all of these things. Now, talking about perceptron, our next question, what an interviewer might ask is explain the learning of a perceptron. So basically, a perceptron has four steps of learning. So the first steps is initializing the weights and threshold. So just now, as I mentioned, initializing the weights and threshold so to the perceptron so that it can activate a neuron by calculating the weight, its sum, and further adding the bias in and all. This is the first step. And the second step is providing the input and calculating the output using the activation functions. And according to that, what we do is the third step involves updating the weights. Now, once a particular perceptron learns something, it has to update the weights so that it can learn much more things in a new manner. And the next step, what comes is to repeat the step number 2 and 3, which is provide the input and calculate the output and then update the weights accordingly. Now, if we have a look at the equation here, we have wj plus 1 that equals wj of t plus n of t minus yx. The wj of t plus 1 is the updated weight, whereas wj of t is the old weight, d is the desired output, y is the actual output, and x is the input. So this is the equation of the learning of a perceptron. Now the next question is, what is the significance of a cost or a loss function? So a cost function is a measure of accuracy of the neural network with respect to a given training sample and expected output. It provides the performance of a neural network as a whole, and in deep learning, the goal is to minimize the cost function. So for that, we use the concept of gradient descent. Now, which brings us to the next question, which is what exactly is gradient descent and what are its various types? So gradient descent is an optimization algorithm which is used to minimize some function by iteratively moving in the direction of the steepest descent as defined by the negative of the gradient. Now think of it as a bowl in which you start from any particular point and the goal is to reach the bottom of the bowl, which is the gradient descent. So there are three types of gradient descent, which are the stochastic batch and the mini batch. So stochastic gradient descent, it uses only single training example to calculate the gradient and update the parameters accordingly. Whereas the batch gradient descent calculates the gradients for the whole dataset and performs just one update at each iteration. Now, mini batch gradient descent is a variation of the stochastic gradient descent where instead of single training example, mini batch of samples are used, and it is one of the most popular optimization algorithm. Now, if we talk about mini batch gradient descent, one might ask is what are the benefits of the mini batch gradient descent, or how is it useful than the others? Now, the mini batch gradient descent is more efficient when compared to the stochastic gradient descent, and the generalization is done by finding the flat minima, which allows to help approximate the gradient of the entire training set, which help us to avoid the local minima. Now, this is why mini batch gradient descent is considered or is preferred over the regular gradient descent algorithm, which is the stochastic gradient descent. Now, one might ask, what are the steps for using a gradient descent algorithms? So, first of all, what you need to do is initialize some random weight and bias. And after that, you need to do is pass an input through the network and get values from the output layer. Next, what you're going to do is calculate the error between the actual value and the predicted value. Now, this can be done in a number of ways. Now, the next step involves is to go to each neurons which contributes to the error and change its respective values to reduce the error, which is basically our goal is to reduce the cost of any particular function or any particular model. So after that, what you do is reiterate until you find the best weights of the network and you find the lowest cost of the particular network. So one might ask you to write any gradient descent program or write the pseudocode of any gradient descent program. So what you need to do, first of all, what we do is define the parameters, which are the weights, the hidden weights, the weight output, the bias hidden, and the bias output. We define a function std with arguments as cost, the parameters what we have discussed, and the learning rate. Now, what we do is we then define the gradients of our parameters with respect to the cost function. So here we use the Theano library to find the gradients and we import Theano as t. And finally, iterated through all the parameters to find out the updates for all the possible parameters. So you can see that we use vanilla gradient descent here, and as you can see, it returns the updates, and what we do is update the parameters and the cost in this particular equation. The ultimate goal of any gradient descent algorithm is to minimize the cost. Now, talking about Perceptron, what are the shortcomings of a single layer Perceptron? So, well, there are two major problems. Now, first of all, is that the single layer perceptron cannot classify non-linear separable data points. And the second point is that the complex problems that involve a lot of parameters cannot be solved by a single layer perceptron. Now, consider an example here and the complexity which arises when the parameters are involved to take a decision by a marketing team. So, first of all, we have the categories, which are the email, direct, paid, referral program, or the organic. And inside this category, we have subcategories, which are the Google, Facebook, LinkedIn, Twitter, we have Instagram now. And inside that, we have the type of subcategory, which are the search ads, remarketing ads, interested ads, lookalike ads. And again, if we do a subdivision, we have the parameters to consider, which are the customer acquisition cost, we have the money spent, the click rate, or the lead generated, the customer generated, and the time taken to become a customer. So one neuron cannot take in so many inputs, and that is why more than one neuron would be used to solve this problem. Now, which brings us to the question, what is a multi-layer perceptron? So a multi-layer perceptron, or MLP, is a class of feed-forward artificial neural network, and it is composed of more than one perceptron. They are composed of an input layer to receive the signal, an output layer that makes a decision or the prediction about the input, and in between these two, an arbitrary number of hidden layers that are the true computational engine of any multi-layer perceptron. Now, one might ask, what are the different parts of any multi-layer perceptron or a neural network? So first of all, what we have are input nodes. So the input nodes provide information from the outside world to the network and are together referred as the input layer. No computation is performed in any of the input nodes. They just pass the information to the hidden layers. Now, hidden nodes have no direct connection with the outside world, hence the name hidden. And what they do is they perform computation and transfer the information from the input nodes to the output nodes. Now, a collection of hidden nodes forms the hidden layer, and while a network will only have a single input layer and a single output layer, it can have 0 to n number of hidden layers, and a multi-layer perceptron has more than one hidden layer. Now, if we talk about output nodes, the output nodes are collectively referred to as the output layer and are responsible for the computation and transferring information from the network to the outside world, and hence they are also responsible for the prediction. Now, coming to our next question, what exactly is data normalization and why do we need it? Now, data normalization is a very important pre-processing step, which is to normalize the data. The data should not be either left skewed or right skewed. It should be normal, and it's used to rescale the values to fit in a specific range to assure the better convergence during backpropagation. And in general, it boils down to subtracting the mean of each data point and dividing by its standard deviation so that we get a normally distributed data. And it makes computation easy in terms of the backpropagation in case of a neural network. So this is a very important part of any deep neural network. Now, talking about deep neural networks, or neural networks in general, coming to our next question, which is, now what is better, the deep networks or the shallow ones, and why? Now, both the networks, be it shallow or deep, are capable of approximating any function. What matters is how precise that network is in terms of getting the result. Now, a shallow network works with only a few features as it cannot extract more, but a deep network goes deep by computing efficiently and working on more features or the parameters. Now, deeper networks are able to create deep representation. At every layer, the network learns a new, more abstract representation of the input, and hence deep neural networks are better than the shallow ones. So, what exactly is weight initialization in a neural network? Now, as we saw, we had weight initialization in perceptrons. So, weight initialization is one of the very important steps. A bad weight initialization can prevent a network from learning, but good weight initialization can help it in giving quicker convergence and a better overall error. Now, biases can be generally initialized to zero. The rule for setting the weights is to be close to zero without being too small, because every time the weight is being multiplied to the inputs, the result gets smaller and smaller. Now, talking about neural networks, what is the difference between a feed-forward and a backpropagation neural network? Now, a feed-forward neural network is a type of neural network architecture where the connections are fed forward, that is, they do not form cycles. The term feed-forward is also used when you input something at the input layer and it travels from the input to the hidden and from the hidden to the output layer. The values are fed forward. Now, backpropagation is a training algorithm which consists of two steps majorly. The first one is feed forwarding the values, and the second one is to calculate the error and propagate it back to the earlier layers. So, to be precise, forward propagation is a part of backpropagation algorithm, but it comes before the backpropagation. So one might ask the question, which is one of the most important questions, is that what are the hyperparameters in a neural networks, and name a few of these hyperparameters. So hyperparameters are the variables which determine the network structure. That is, for example, the number of hidden units and or the hidden layers, and the variables which determine how the network is trained. For example, the learning rate. So there are two types of hyperparameters usually. One are the network parameters which are associated to the network. In that case, we have the number of hidden layers, we have the network weight initialization, we have the activation function. And in the training parameters, we have the learning rate, we have momentum, number of epochs, we have the batch size, and much more. Now, a lot of hyperparameters also differ when we work along with different types of neural networks. So, as in CNN, we get extra parameters to work on when considering CNN, which are the convolutional neural networks. And sometimes we have to deal with less number of hyperparameters. It all depends upon the type of neural network which you are using. So, which brings us to the next question is that explain the different hyperparameters related to networking and training. So in training, we have, first of all, we have the number of hidden layers. So hidden layers are the layers between the input and the output layers, as we just discussed. And many hidden units within a layer with regularization technique can increase the accuracy, and smaller number of units may cause underfitting. Now, another important aspect is network weight initialization. So ideally, it may be better to use different weight initialization schemes according to the activation function used on each layer. Mostly uniform distribution is used, or the normal distribution. Now, if we talk about activation function, so they are also used to introduce non-linearity to the models. They are also used to introduce non-linearity to the models, which allows deep learning models to learn non-linear prediction boundaries. Now, generally, the rectifier activation function, or the ReLU, is the most popular. Now, if we talk about the training parameters, so these were the network parameters which have to be initialized to a deep neural network before the training begins. And just before the training, we have the training parameters, which are the learning rate. So the learning rate defines how quickly a network updates its parameter. Low learning rate slows down the learning process but converges smoothly. A larger learning rate speeds up the learning but may not converge as smooth as a low learning rate. Usually, a decaying learning rate is preferred so that we get the best of both worlds and we get the best expected output. Now, another hyperparameter is momentum. So, momentum helps us to know the direction of the next step with the knowledge of the previous step. Now, it helps to prevent oscillation, and a typical choice of momentum is between zero point 0.5 to zero point 0.9. Now, if we talk about the number of epochs, so epochs is basically iterations. So, number of epochs is the number of times the whole training data is shown to the network while training. So increase the number of epochs until the validation accuracy starts decreasing, even when tiering accuracy is increasing. So that results in sometimes overfitting. And if we talk about the batch size, so mini batch size is the number of subsamples given to the network after which parameters update happen. So a good default for batch size might be 32 or 16, 64. It depends upon the size of, the data you have. It can be any arbitrary number, but it's always better to have it in the power of 2, right? So while we were talking about overfitting, which brings us to our next question, which is what exactly is a dropout? So dropout is a regularization technique to avoid overfitting, which is to increase the validation accuracy, thus increasing the generalization power. Now, generally use a small dropout value of 20% to 50% of the neurons, with 20% providing a good starting point, and a probability too low has minimal effect, and a value too high results in underlearning by the network. So first of all, what you need to do is use a large network, and you are likely to get better performance when the dropout is used on a larger network, giving the model more of an opportunity to learn independent representation. Now, our next question is, in a neural network, you notice that the loss does not decrease in the few starting epochs. So what could be the possible reason for this to happen? Now, the correct answer is the reason for this could be the learning rate is low, first of all, or it might be the regularization parameter is high, or it can be it is stuck at local minima, so it might take certain iteration to go out of that local minima and finally reach the lowest point. So it might happen in some cases that it is stuck at local minima. So another approach to that sort of problem must be initiated at that particular point of time. Now, talking about deep learning, one might ask to name you a few deep learning frameworks which are being used in the industry. So first of all, the foremost and the most amazing deep learning library is the TensorFlow. Followed by, we have Caffe, we have the Microsoft Cognitive Toolkit, which is the CNTK. We have Torch or PyTorch, which is giving a good battle, or it's standing out from the crowd, and people are sometimes preferring PyTorch over TensorFlow. Now, MXNet is another deep learning framework. We have Chainer and we have Keras. Now, Keras, as you know, can be integrated with Theano as well as TensorFlow, and Keras has been considered one of the best or the simplest deep learning framework when it comes to deep learning. Now, one might ask, what exactly are tensors? So, tensors are nothing but a de facto for representing the data in deep learning. What I meant to say that tensors are just multi-dimensional arrays that allows you to represent the data having higher dimensions. In general, deep learning, you deal with high dimensional data sets where dimensional refer to the different features present in the data set. So what you need is a multi-dimensional sort of array or a data structure, what you could say. So that's what exactly tensor is. And in fact, the name TensorFlow has been derived from the operations which the neural network perform on tensors. So it's literally a flow of tensor. Now, talking about TensorFlow, one might ask, since it's the most popular deep learning framework and companies prefer people having the knowledge of TensorFlow and been working on it. So what are the few advantages of TensorFlow? So first of all, it has the platform flexibility. It is easily trainable on CPU as well as GPU for distributed computing. Now, TensorFlow has auto differentiation capabilities, and it has advanced support for threads, asynchronous computation, and it is a customizable and open source framework. And most importantly, if we talk about the latest TensorFlow 2.0, which has just been released, so those come up with a lot of interesting features, and it has adopted Keras as its high-level API fully, so that the coding aspect of it is much simplified, and eager execution is now by default, so that you do not have to write loads and loads of line of code. And if you want to know more about TensorFlow 2.0 and why it's the best deep learning framework in the industry right now, just go ahead and check our TensorFlow 2.0 video. I'll leave the link in the description box below. Go check it out, guys, and understand how exactly is it better from the previous version and why it is the best deep learning framework right now. Now, talking about computational graphs, one might ask what exactly they are. So, well, a computational graph is a series of TensorFlow operations arranged as nodes in the graph. Now, each node takes 0 or more tensors as input and produces a tensor as output. Now, basically, one can think of a computational graph as an alternative way of conceptualizing mathematical calculation that take place in a TensorFlow program. Now, the operations assigned to the different nodes of a computational graph can be performed in parallel, thus providing better performance in terms of computation. So, one might ask, what exactly is a convolutional neural network? Now, a convolutional neural network, or CNN or ConNet, is a class of deep learning neural networks which is most commonly applied to analyzing the visual imagery. So, CNN use a variation of the multi-layer perceptron designed to require minimal processing. Now, one might ask the next question: if you are going for an interview which requires you to work with a lot of images or videos, so in that case, CNNs are very much used. So, having a good knowledge of CNN is always better in that case. So, the next question which we have here is, what are the various layers of CNN? Now, there are four layered concepts everyone should understand in convolutional neural networks are: first, the convolutional layer; the second is the ReLU layer, and finally we have the pooling layer, and finally we end up with the full connectedness or the full connected layer. Now, if we talk about CNN, we have to talk about RNN also. So one might ask, what exactly is RNN? So RNN, or the recurrent networks, are a type of artificial neural networks which are designed to recognize the patterns in the sequence of data, such as text, genomes, handwriting, the spoken word, numerical time series data from sensors, the stock markets, and the government agencies. So recurrent neural networks use backpropagation algorithm for training, but it is applied for every timestamp. It is commonly known as backpropagation through time, which is BTT. Now, our next question is, what are some issues faced while training an RNN? So, recurrent neural networks use backpropagation algorithm, as I just mentioned, for training, but it is applied for every timestamp. And there are some issues with backpropagation, such as vanishing gradient or the exploding gradient, where the gradient vanishes or it is too much to handle. Which brings us to the next set of questions, the first of which is, what exactly is a vanishing gradient and how is it harmful? Now, when we do backpropagation, that is move backward in the network and calculating gradients of loss, which is the error, with respect to the weights, the gradients tend to get smaller and smaller as we keep on moving backward in the network. Now, this means that the neurons in the earlier layers learn very slowly as compared to the neurons in the later layers in the hierarchy. Now, the earlier layers in the networks are the slowest to train. Now, how is this harmful? So, earlier layers in the neural networks are important because they are responsible to learn and detect the simple patterns and are actually the building blocks of our neural network. Obviously, if they give improper and inaccurate result, then how can we expect the next layer and the complete network to perform nicely and produce the accurate result? So the training process takes too long and the prediction accuracy of the model will decrease. Now, another question here arises is, what exactly is then exploding gradient descent? Now, this is just the opposite of vanishing gradient descent. So exploding gradients are a problem when large error gradients accumulate and result in very large updates to the neural network model weights during training. So the gradients are used during the training to update the network weights, but typically when this process works best is when these weights are small and controlled, when the magnitudes of the gradients accumulate and the unstable network is likely to occur, now which causes a poor prediction and results, or even a model that reports nothing useful whatsoever. So vanishing gradient and the exploding gradient are two problems which occur while the backpropagation happens in a recurrent neural network. So our next question is, what are LSTM? So long short-term memory, which are the LSTM, is an artificial recurrent neural network architecture used in the field of deep learning. And unlike standard feed-forward neural networks, the LSTM has feedback connection that make it a general-purpose computer. Now it can not only process single data points, but also the entire sequence of data. They are a special kind of RNNs, or the recurrent neural network, which are capable of learning long-term dependencies. Now one might ask, what are capsules in a capsule neural network? So capsules are vector, or what we can say an element with a size and a direction, specifying the features of the object and its likelihood. Now these features can be any of the instantiation parameters like the pose, we have the position, size, orientation, deformation, velocity, the albedo, which is the light reflection, hue, texture, and much more. A capsule can also specify its attributes like angle and size, so it can represent with the same generic information. Now, just like a neural network has layers of neurons, a capsule network can have layers of capsules, so there could be higher capsules representing the group of objects or the capsules below them. Now, this helps in getting deeper knowledge of a particular object or a particular data set and having the knowledge from different aspects or different angles. So the next question arises is explain autoencoders and its uses. So an autoencoder neural networks is an unsupervised machine learning algorithm that applies the backpropagation, setting the target values to be equal to the inputs. So autoencoders are used to reduce the size of our inputs into smaller representation. And if anyone needs the original data, they can reconstruct it from the compressed data. Now, one might ask the question, how does autoencoder differ from PCA? So, an autoencoder can learn from nonlinear transformation with a nonlinear activation function and multiple layer. It does not have to learn dense layers. It can use convolution layers to learn, which is better for video, image, and series data. It is more efficient to learn several layers with an autoencoder rather than learn one huge transformation with the PCA. An autoencoder provides a representation of each layer as the output and can take the use of pre-trained layers from other models to apply transfer the learning to enhance the encoder or the decoder. So these are few of the reasons why autoencoders are better from PCA, as we know both of them perform the same task, which is mostly dimensionality reduction. Now give some real life examples where autoencoders can be applied. So the first of all, we talk about dimensionality reduction, or the first thing that should pop up in your mind is dimensionality reduction. So the reconstructed image is the same as our input image but with reduced dimensions. Now it helps in providing similar image with reduced pixel value, and it can be used in various areas where we have limited storage or we have limited processing power. So when there is a high input or an image or a data with high dimension or which has higher values, pixel values, it can compress and provide the same image with a lower pixel value. Now, autoencoders are used for converting any black and white picture into a colored image, believe it or not. And depending on what is in the picture, it is possible to tell what the color should be. Now, feature variation, if we talk about feature variation, it attracts only the required features of an image and generates the output by removing any unnecessary noise or unnecessary interruption. And if we talk about denoising image, the input seen by an autoencoder is not the raw input, but a stochastically corrupted version. A denoising autoencoder is thus trained to reconstruct the original input from the noisy version. Now, talking about autoencoders, one might ask about the different layers of the autoencoders. So, basically, an autoencoder consists of three layers, which is the encoder, we have the code, and the decoder. Which brings us to the next question, explain the architecture of an autoencoder. If we talk about the three layers, which are encoder, code, and decoder, so if we talk about encoder, this part of the network compresses the input into a latent space representation. Now the encoder layer encodes the input images as a compressed representation in a reduced dimension, and the compressed image is the distorted version of the original image. Now coming to the middle part, which is the code. So this part of the network represents the compressed input which is fed to the decoder. It is basically the channel. And if we talk about decoder, this layer decodes the encoded image back into the original dimension, and the decoded image is a lossy reconstruction of the original image, and it's reconstructed from the latent space representation. Now one might ask, what exactly is bottleneck in an autoencoder and why is it used? Now the layer between the encoder and the decoder, that is the code, is also known as bottleneck. So this is a well-designed approach to decide which aspect of the observed data are relevant information and what aspects can be discarded. It does this by balancing two criteria. The first, the compactness of the representation measured as the compressibility, and second, it retains some behaviorally relevant variables from the input. Now, one might ask, are there any variation of autoencoders? Surely there are. So There are convolutional autoencoders, we have sparse autoencoders, we have deep autoencoders, we have contractive autoencoders. All of these autoencoders have a different structure or the different code layer. If we talk about the convolutional autoencoder, we have the convolutional CNN algorithm sort of structure in that particular autoencoder with encoder in one side. We have the convolution layers, the ReLU layer, the pooling layer inside it, and then finally we have the decoding layer. So another question what might pop into the interviewer's mind is what are deep autoencoders? So the extension of simple autoencoders is a deep autoencoders. The first layer of the deep autoencoders is used for first order features in the raw input. Now the second layer is used for second order features corresponding to the patterns in the appearance of the first order features. So the deeper layers of the deep autoencoders tend to learn even higher order features. So our deep autoencoders is composed of two symmetrical deep belief networks. First four or five shallow layers representing the encoding half of the net, and the second set of four or five layers that make up the decoding half. Interesting, right? So another important topic in deep learning are the restricted Boltzmann machines. So one might ask what exactly is an RBM or restricted Boltzmann machine. So RBM is an undirected graphical model that plays a major role in deep learning framework in recent times. And it is an algorithm which is used for dimensionality reduction. Not only that, it is used for classification, regression, collaborating filtering, feature learning, and topic modeling. So when we talk about RVM being useful for dimensionality reduction, another question might arise is how does RVM differ from the autoencoders? So autoencoders is a simple three-layer neural network where output units are directly connected back to the input units. Typically, the number of hidden units is much less than the number of visible ones. And the task of training is to minimize an error or the reconstruction, that is, find the most efficient compact representation for the input data. So RBM share a similar idea, but it uses stochastic units with particular distribution instead of deterministic distribution. The task of our training is to find out how these two set of variables are actually connected to each other. One aspect that distinguishes RBM from the autoencoders is that it has two biases. The hidden bias helps the RBM produce the activations on the forward pass, while the visible layer biases help the RBM learn the reconstruction on the backward pass. Now, this brings us to the final question of our deep learning interview is that what are some limitations of deep learning? I bet you weren't thinking of this one, but there are some limitations. So, deep learning usually requires large amounts of training data, and deep neural networks are easily fooled. Now, the success of deep learning are purely imperial. Deep learning algorithms have been criticized as uninterpretable black boxes. Because one important thing about deep learning is that you do not specify what you are looking for, right? The algorithm learns on its own. So that is one of the shortcomings of deep learning, and deep learning thus far has not been well integrated with prior knowledge. So a lot of people still don't feel it as a way to solve their problem, as a way to approach to their problems, because a lot of people don't understand what exactly is deep learning, how it works, how to initialize all of the variables, which are the hyperparameters per se. These all things are some limitations of deep learning as of now, and we hope by the time technology advances, people get to know more about what deep learning is, how artificial intelligence can be achieved through deep learning. They'll be more open to this, and all of these limitations will be laid off. So, guys, that's it from my side, and I hope you got to know a lot about deep learning interview questions, which might help you in cracking the interviews and landing a great job as data scientists, machine learning engineers, or artificial intelligence engineers, as a matter of fact. And one important thing, what I would like to say is that data scientists' role are somewhat, industry specific, or I would say if you are working in healthcare, you should know about healthcare industry too, rather than just knowing about the data and the numbers. So if you are working in, suppose, imagery, so you should know about images, you should know what you're dealing with. So a good knowledge of the particular industry which you're working for will also provide you a great advantage over other competitors. And since you know a lot of this stuff with this video, I'm sure you might be able to land a job a great job in any of these industries. So till then, guys, thank you and happy learning.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!